Good afternoon, everyone. I would like to start by thanking the opportunity to share some ideas that I have about smart cities in such a remarkable forum. It's quite a different topic, but I think it may be interesting for us to understand some of the things. So my name is Seca. I come from INESC. INESC is a private research association seated in Porto, and we do a lot of research in the electrical power system, and it's about energy that I'm going to talk to you a little bit today. Why is it relevant to talk about energy, and why is everyone now concerned about sustainability and to the future generations? Because in fact, we inherited a planet that was in a very good condition, and what we have seen over the last years is that it has been degrading, and the expectations for the upcoming generations are concerning, because it is a fact that global warming is happening and something needs to be done on this. What are the causes for this global warming? Some of them are quite easy to understand, others aren't that much easy, but we will talk a little bit about that. So most of them come naturally from the combustion of fossil fuels, either to, let's say, convert these primary sources into electricity that we use a lot everywhere, for transportation and also in industry. How is it spread? If we look at this image, we see on the left, it's how we use this energy referred to its primary energy. So primary energy, we have petroleum, natural gas, hydro, wind, solar, biomass, etc. So what we see from this picture is that most of the energy that we use it as electricity. The other part is naturally divided. There is also a significant part that is used to feed our transportation. But if you look at the sectors, we see that buildings and transportation are in fact the major energy users. So if we want to change the paradigm, if we want to increase the level of renewable-based energies, and if we want to decrease greenhouse gas, we need to tackle these two sectors. Oops. Where do we use it? In fact, we see that nowadays about 54% of the population lives in large urban areas. That is why this focus on smart cities is important, because the fact is that the tendency will be for about 6 billion people to live in cities in 2045. So the density of people living in these areas, when compared to other types of cities, smaller cities, rural areas, will be significant. Of course, if there is a lot of people in the cities, if we use that energy, for sure, this will be the place where the most energy will be used. And so we can see that up to now, almost 2/3 of the energy is consumed in cities, and more than 70% of these greenhouse gas emissions can be, let's say, directly pointed to these cities. Of course, when we talk about sustainability, it is clear that sustainability will only be achieved if we do care about these issues. And so we need to start thinking on it, not in such a, let's say, economical vision, but more in an integration of these natural resources as something that is natural, something that we need to do to guarantee, let's say, our future generations. What are the opportunities in cities? Of course, there is a lot to do when it comes to buildings. Most of you have heard a lot about this. Everyone talks about solar panels, about efficient appliances, electric machine dishwashers that are more efficient, LED lighting, everything around the building, so building energy management systems, automation, connection, disconnection, everything is there, so the technology is there. There is a lot also about transports and mobility that needs to be done. in Portugal, there is a significant number of people that still travels alone. And this is a tendency that is not only from our country. A lot of countries still use the automobile as their main travel way. So everyone talks about EVs. EVs is the trend line now. Everyone sees EVs starting to appear. So it is a way, if they use renewable-based energy, because if they use fossil fuel energy, it will be, it's even worse, in fact, because the losses that we have in the whole electric system, as it was conventionally, to charge an EV, if they use fossil fuels, the efficiency can be less. So it's not about just connecting the cars to a plug. We need to understand how we can use the local resources to feed these vehicles for them to be actually sustainable. And then, of course, there's a lot about energy governance. We know that the policies and the trends that cities need to have are mostly important for these measures to take place. It's not about having just a technology. We need to have a strategy. We need to have these policies. And today we will talk a little bit about these topics that are in red. They are more from this area that I'm going to bring you some insights about the power systems. So, if we need to reduce greenhouse gas, what can be done? One way is to be more efficient when we use the energy. Another way is to integrate these renewable sources. Renewable energy integration is something that has happened all over Europe. Everyone has seen in every country. Portugal, in fact, is one of the most, let's say, interesting countries because we do have a lot of sun, but we do not have a lot of solar power, but we are one of the biggest in terms of wind integration. So we have a peak demand around 10 gigawatts, and we have almost 5 gigawatts of installed capacity in wind. So this demonstrates the tremendous effort that the country did to try to integrate these renewable-based energy sources. Of course, more recently, we see the use of other technologies on using solar photovoltaics in the facades of the buildings, using biogas. There is a lot of alternatives that can be used, but the fact is that the easiest, let's say, renewable-based technologies are the ones that we can see on the top, and that Portugal has a lot, that is wind and water, hydropower. When we talk about efficiency, what I was mentioning about the EVs, we usually do something that is called the well-to-wheel analysis, where we analyze the efficiency, the overall efficiency of the use of this energy. We can understand why. Here we see that the efficiency of the overall process of the classical electrical system will have a significant loss in terms of energy that is converted in the large generating units until we use it in our households. So only around 36% will be available where we use it. So this is something that makes it clear that if we increase efficiency locally, we will have more efficient gains, more concrete gains, to be redundant. So what is the difference? What you saw in the other picture was we used to have large generating units, large power plants, nuclear power plants, coal power plants that injected this electricity in the transmission system up to the distribution system until we have it in our plugs and in all our appliances. What we started to see now is that these distributed generation units, these solar panels, this wind, starts to appear in other areas of the network where it was not originally existing. What is the problem? The network was designed to have an injection on one side and a consumption on the other side. It was not designed to have all these sources in the middle. So managing all this has become an issue. If you associate this with the fact that most of these units are renewable based, we cannot ask the sun when to shine or the wind when to blow. It will blow when it blows, and we will have sun when we have it. And in the places where the resource is, not where we want. We can build a power plant where we want, but we cannot have wind where we want. So all of this makes it very challenging to manage the electrical system, and this is not the future, this is already the present, because a lot of this has happened. Probably the most, let's say, famous case is Germany. Germany decommissioned a large number of nuclear power plants. They started, let's say, feeding through tariffs the integration of solar panels, and then a lot of electrical problems appeared because the network was not prepared to have all that generation in the places where usually it was to be used. And so this needs to be challenged, and this is a challenge that needs to be tackled. What I was mentioning about the renewables, one thing is important to say is that usually when we have most of the resource we are not using. The peak production of solar photovoltaics is around noon, for example, and our peak demand is at night when we are at home. There is no sun. So there is a clear shift between these two, let's say, resources. And so to be efficient and to use this energy, we need to take different measures because they naturally do not appear at the same time. What can be the impacts? Here you have some images of electrical networks in two different cases. The first case upstream about res integration is what can happen if you have a lot of solar photovoltaics in a certain area of the network. All the solar panels are south-oriented. Usually they are close to each other, meaning that if there is a lot of sun and if people are not in their households, you will have a lot of generation that will not be used. If it's not used, it should be injected in the network. So you'll have a reverse flow, which can cause technical constraints in the network because it's completely simultaneous, what does not happen with our loads. We are not all at the same time at our households using every appliance we have. We all have different behaviors, but the solar panels will all produce the same at the same time. So this is an issue. The same thing happens with electric vehicles. We are neighbors, 10 neighbors. We have dual tariff. It's cheaper electricity at 10 p.m. What will everyone do? We will all charge our vehicles exactly at 10 p.m. Will the network be capable to satisfy all this consumption? For instance, a significant number of households has, let's say, a contracted power that is lower than a BMW i3 can ask in a certain moment from the network. So it means the whole installation may not have the condition to satisfy. When power engineers design these networks, they design them assuming these simultaneously among different customers. They do not expect everyone to have everything connected at the same time. So if they do connect it, this will be an issue. So again, a smart city needs to integrate these local resources, needs to be capable to deal with this electric mobility. Mobility is a very important pillar of these smart cities, but there are issues that need to be solved. So this means that the overall management of the network should follow this buzzword that most of you might have heard, that is smart grids. Is something that has been done over the last years, where the fact that, and that is where we have the bridge to this conference, we started having ICT, we started having communication, something that did not exist in the beginning. So you have the power system cables, you have energy was flowing from one point to the other, there was no capacity to understand what was happening because communication was scarce, and let's say the dimension of the system was not increasingly high as it is today. So for us to be able to manage all of this from generation to our consumption in our households, we need to have a system that has the capacity to receive the relevant information, to use the proper ICT, and always to understand how do customers engage with all of this. Because in the end of the day, if people don't care about this, this would mean nothing. So we need to create the condition for people to understand and people to participate in this. That's the only way we can do it. This picture explains a little bit what I'm trying to say in words that is not easy for everyone to understand, but this could be what two different households in a low voltage network, so this means what we have here. And let me show what happens when, for instance, if everyone starts charging their EVs at the same time, you'll have all this amount of power that will lead to some degradation. This is voltage. Voltage is a concept that I'm not sure everyone is familiar, but well, we need to have 230 volts for everything to work in our plugs. If there's not 230 volts, things will start not working, and we will not be capable to use all the appliances to charge the computer, to connect the TV, and so on. It's a technical conditions for things to operate. If everyone starts asking power at the same time, this is what will happen. We will go backwards in time. Some of you may remember in rural areas for some years, when the power grid did not have the capacity, some things would not work after a certain time. For instance, at peak hours, some lighting that uses fluorescent technology could not start because the electromagnetic ballast did not have enough voltage to work. So this is a primary condition of quality of service that the DSO is responsible to provide. That is the reason why the DSO started in advance talking a little bit about these issues and then developing projects and architectures that will be able to tackle all of this, because they are the ones that need to handle the power with the quality that is defined, that is the 230 volts. What can we do about this? If instead of leaving it this way, we can have systems that have the capacity to understand the limitations and the sensors and the communication, what we can do is, if the network has no condition to deal with all of this, we can send signals, for instance, for those EVs. This is something that can already be done, and most of the manufacturers have the capacity to use these pilot control signals to reduce the amount of power the cars are absorbing at the same time, and bring the system back to security. But let us imagine a different scenario. If it's noon and we have a lot of sun and there is also wind, what can happen is that this injected power may lead to the opposite effect. That is, voltage will tend to be high. What has been the decision so far is, well, we do not have the capacity to receive all this power, we will curtail. So we will waste a resource that is renewable because we do not have the technical conditions to absorb it. Either we reinforce the whole network, which would be extremely expensive and difficult to do, or we can integrate intelligent management systems, the so-called smart grid, that can solve these issues without the need of making these reinforcements. How? At this moment that you have a lot of renewable generation, for example, if we send a signal to increase the load, and by increasing the load we are talking about EVs, but we could be talking about storage. What will happen to the batteries that will leave these electric vehicles in 3 years? Will they be waste? Can't we use them to put inside our households to keep the energy that we produce at noon to use at night, having this concept of almost net zero balance to buildings and households? So we will be capable to use the energy in a more intelligent way. But for this to happen, someone that is managing the infrastructure needs to have the means to do so. And so a few years ago, we started working a lot on this. I would say that it is a sector that started pretty early, taking advantage of these communication infrastructure. This is a demonstration that we did, and my colleague Antonio from EDP will make another presentation on this. We have been working with EDP for many years on these topics. And we took this concept that I showed in that previous picture, we took this concept to the real test field, and we were able to install in Évora, that for the people who doesn't know, maybe Antonio will talk a bit about that. was considered the reference pilot of smart grids all over Europe. And we started this in 2007 or 8. It's when the project began. So 10 years ago, we started thinking on these things. And we were able to demonstrate these concepts. So to a lot of people that the technology is there, what we need to do is bring intelligence into the systems and take advantage of this communication. We were able to, for instance, if there is a lot of sun and we made a demonstration, it was a cloudy day, then the cloud was removed and we had a lot of sun and the EV started charging automatically. This is the sort of thing that we need to do, but people need to be integrated without having the need to be constantly interacting with the system. Electricity is something that all of us have as guaranteed. If we don't have electricity, this will be a major issue because in a few hours the batteries will run out and everything will stop working. So it is the sort of thing that we do not think. I still honestly think it is too cheap for us to think about that, although everyone thinks it is expensive. The problem is that it is too cheap. So we still leave some lights on and we still leave the refrigerator open and we still do a lot of things that we do because electricity is cheap. Because when we talk about gasoline, everyone gets nervous. But the fact is that we do a lot worse in terms of electricity usage, for example, than we do for our petrol and for other fuels. So how can we implement this with dimension? The first thing is that we must continue this effort, and DSOs have made this, to increase their knowledge, their capacity to monitor, their capacity to receive information from sensors and from other, let's say, instruments that they can have to support their operation. We need to have forecasts. It is important to understand what will happen in the next hours. If we want to know how we are going to use this energy. Will today be a sunny day? Yes, it will. So let us keep this energy. If it's not, we will make a different scheduling of our loads. But this is something that should be passed to end users. They need to understand the value of making this, but the systems must be simple and intuitive and automatic. No one will connect dishwasher machines if they receive an SMS saying electricity will be 2 cents cheaper. If you say it's a 50% discount, they will get excited. But when you explain that that's 50% discount will value €2 after a year, most likely they won't do anything. But if you are able to receive their preferences and understand what do they need, how many kilometers does the vehicle need to have at 7 when a person will leave the house? And if you say we need 30, let the system manage. Let the system decide when it's best to charge the vehicle, when we have more renewables, when electricity is cheaper. It's all about this that we are trying to implement. As you saw in the previous pictures, we have spoken a lot about digitalization, but there are some specific challenges from the power systems that need to be tackled. So it's not thinking that the power system is like internet, where now everything can communicate with everyone, because there is a lot of technical restrictions that we need to tackle. Of course, the basics was energy, but I must make some advertising from my city. I'm sorry, we are in Lisbon, we always take this opportunity. Porto has been doing a very interesting work on other pillars, also in energy, but in other pillars that I consider somehow interesting to bring here to this conference. There is a lot of sensing and a lot of Wi-Fi using over buses. This is something that you can see in detail. It's not my area of expertise, communication, but there is one thing that I decided to bring you here that I found interesting. That is this Sense My City concept, where my colleagues have developed a lot of work in terms of mobility. We have seen a lot about the impact that transportation has in cities. So it's fundamental that we look at mobility, look at electric mobility, but also on the way people behave for us to understand what should be the policies to move on and to foster this integration. And so one of the more interesting ones that I found is that they have these sensors that they receive in terms of mobility patterns and so on, but we also have a very interesting group that works on wearables to make diagnosis for people's health and so on. And they were actually able to integrate these applications on sensing the cities and this philosophy of crowd sensing together with these health products connected with these wearables, and they were able to identify, they place these wearables in public transportation drivers and try to understand what were their stress levels in the city. And it was very interesting to see, for example, that in that particular, Porto has 5 bridges from Gaia to Porto. And there is one bridge that has a very particular curve at the end of it that is quite a tricky curve. It seems easy, but when you get there, it's... And so we could see that for a sample of 150 bus drivers, all of them increased their stress levels to double in that particular curve. So, smart city and sensing and IoT is all about this, is let us try to get this information, and this information would be vital, for instance, for planning. We could understand that a certain bus line, if the bus drivers are always stressed out in the same area, maybe that's a sign that we need to change that line. So the city is, let's say, taking advantage of these projects to understand and to study itself. We have also done a very, let's say, important work in terms of energy, and this is something that we are also working hard to bring. But I thought this would be a very interesting example for you to see what is being done now. And the results of these projects have been very, very interesting, so I invite you to visit the Porto Living Lab, where they have this slogan, towards a sensitive city. And that's it, what I had to talk about.
I think that's an excellent example. It reminds me of a famous old joke, which I'll share with you now. My father was a bus driver, and I want to die peacefully in my sleep like him, not screaming in terror like his passengers. Yes. So, anyway, no, he wasn't a real bus driver. That was absolutely brilliant. And for once now, I think you gave one of the best explanations of how the smart grid ought to look that I have heard for some time. So I do appreciate that. Are there questions? I know we have another session on a similar topic just following. Yes. So maybe we should reserve questions until the end of this essentially double-headed session. So if no one has questions now, then there is a gentleman at the back, which is fine. But meanwhile, I don't know where Antonio is, so we need to know where he is too. Okay, perfect.
A quick question. I did not hear you talk about the challenges that are blocking the energy efficiency, and would like to pick up your brain on battery and legislation. To me, you've explained very well the technological capabilities, but the question comes, so why it's not happening? And the 2 points that come to mind that would be interested to hear your view on is battery capacity storage and legislation.
I did not hear you perfectly, but I think I understood what you were saying. So, from the efficiency point of view, I would say that it is something that is moving on and is taking place. The issue is that I think the business model associated with the energy sector is something that is changing. Energy, when you have a lot of integration of renewables, for example, the levelized cost of energy will decrease significantly. It means that the margins that you will have will be lower, and so this integration will only take place if retailers start selling services and not only energy. It's like you will be promoted to change your attitude if you receive the condition to do so. if I go into your household and I say, you will have this price, but I will give you this equipment, and if I need between 2 and 5, I can change the overall limitation in terms of power of your household. You will accept to change your behavior. And I will ask you, but what will I benefit from that? If this benefit is something that people start to understand, if it's something tangible, they will shift. What you saw here was a tremendous modernization of the electrical power system. Now the tremendous work that needs to be done is at the consumer level. It's where we need to make the most effort. And this is something that has been happened. Storage is a player that can be interesting. I think it didn't move earlier because of some regulation barriers, particularly with DSOs, because there was a problem that a DSO is someone that is responsible to manage the grid, to provide quality of service, but he cannot earn with the unbundling of the system. He cannot earn with this activity. If you are going to store this electricity at the moments where you have more, and you will make it available after, will that be considered a business for the DSO or not? Will they be able to consider that as an active they can control? It's a different thing. Another thing will be storage at household level. That is something that is going to move on. I invited to see something that was published today about a project that is going to start in Germany about the blockchain concepts in terms of storage. That will mean that the system operator will be able to control through a platform storage that is distributed among everyone's household, and not necessarily a central high power storage. That's something that has happened, and you have seen a lot of projects on that area. So I think the most work to be done now is to the customers and to make them understand this. Okay?
Okay, I think we need to move to the next presentation, if we will. So thank you once again. That was a great contribution.